G'day everyone, welcome to Lubrication Explained. Today I'm going to have a discussion with Professor Ashlie Martini. She's from the Tribology group, which is the Martini research group at University of California at Merced. Really interesting discussion. We had a lot of common thoughts about linking lubricants to sustainability and the impact that it can have on the world, and the fact that it's just a very undervalued area. So it was really cool to get her take on how do you communicate that message, in a research and government setting versus what I do, which is a little bit more customer facing. Also, she's the first person that I've ever talked to in a professional setting that I know for a fact could kick my ass. She was a former national level judo practitioner, and so just it's nice to know that people have interests outside of their specific research field. Anyway, I thought the discussion was really good. Definitely listen through to the end because I think there were a lot of really good insights. All right, let's get into it. Thank you so much to Professor Ashlie Martini for coming on. You're probably going to be the second victim that I upload to YouTube, so I'm pretty excited about that. The reason I wanted to have Professor Martini come on, she's from University of California at Merced, and so slightly different world, coming from sort of academia and research, but very heavily involved in tribology. I really encourage anyone who's watching this to go and follow her either on Twitter or the Martini Research Group is on LinkedIn as well. They put out some really cool stuff. They've got an awesome video series running at the moment where they do short 30-second to 1 minute videos explaining different aspects of tribology, and I'm finding it really entertaining. I know there's a lot to come. But one of the reasons I wanted to have her on is because we kind of share a common aim, which is, getting people to understand the value, I guess, of tribology and lubrication. And I know, Professor Martini has done a lot of work in that area. And so I'm just really interested to get her thoughts on how, in the research field, do you get more people interested, engaged, and excited about it, and help them to understand the value, because I think that's something that we really struggle with on the industrial side as well. And I guess we'll kind of get into that. So, Professor Martini, thank you so much for joining us. So I guess the first couple of questions would be really around how did you kind of get into tribology? Because I know that's not necessarily your background. Did you was it intentional? Did you fall into it? How did you approach it?
I think I fell into it, and I think that's probably what most people will respond when you ask that question.
Yeah.
I very much doubt that this was an intentional career path for most folks.
Yep.
We fall into it. In my case, I fell into it in grad school, but most of us fall into it and then find out how important and exciting it is, so we stick around.
Yeah. Okay. That's a very similar experience to me, right? I came from an aerospace engineering background, and then was a drilling engineer in the upstream at ExxonMobil for a little while, and sort of fell into tribology as well. But once you fell into it, what made you stick around?
It's a good question, but there's so many things. There really are so many things. Part of it is application oriented, and part of it is science based. I mean, as we know, part of this podcast is to get this knowledge out there. But as you and I know, and some of the listeners for this podcast know, that tribology really matters. So for those of us for whom things like sustainability and green technologies are really important, tribology is fundamental to that. So we want to I'm a mechanical engineer, we want to make mechanical components energy efficient and last a very, very long time. And the best way to do that is through tribology. So from an application perspective and a global and societal impact perspective, there's really no better field in my mind. But on the other end of the spectrum, it's also scientifically fascinating. It's not just one field. Mm-hmm. So as I mentioned, I'm a mechanical engineer. I've had to learn chemistry to figure out what the difference between an ester and an ether was. I had to learn about materials science, some physics. It's totally inherently interdisciplinary. So when you go to conferences, for example, you see people from all these different fields trying to speak each other's languages, and the breakthroughs happen at the interfaces between the languages, so between the disciplines rather. And I think from a scientific perspective, that makes it really, really interesting.
Yeah, that's really interesting too. So in industry, I think the thing that which appeals is almost, if you're a generalist rather than a specialist, it the intersection of so many different applications, right? So even when you get into mechanical engineering, a lot of people get pigeonholed into being, you're a turbo machinery engineer. Like you just look at turbines and compressors versus,
Right.
on the lubrication engineering side, it's every application, right? Whether it's a
Right.
log roller at, a timber mill to turbines, gearboxes, etc. So that always
Yeah,
appealed,
everything
and
that
the
moves.
intersection as well of so many different disciplines, like you were talking about. You have to understand a little. You may not have to know it at a PhD level, but understand a bit of
Right.
chemistry and a bit of physics and a bit of
Hmm.
mechanical engineering, a bit of chemical engineering. Yeah,
Hmm.
that's the thing that had always kind of appealed to me. But I wanted to pick up a little bit on the sustainability angle that you talked about because, again, that's maybe something that is not appreciated specifically with our customers, right? So if I'm a lubrication engineer and I go to a site, um, they don't link the lubricants that they're using necessarily to their business's sustainability goals. So what are some of the kinds of things that maybe you have been exploring, even in terms of let's say going for government research grants and things like that? How do you put sustainability kind of at front of mind?
Another great question. You've got a whole slew of them here. I don't know that I necessarily have to put sustainability at the front of the mind because it's always there for me.
Yeah.
It's one of my motivating factors. It's when I teach or when I'm talking to my grad students or when I'm pursuing funding or doing research,
Mm.
any of those in my mind, I'm gonna use my little air quotes here. I'm trying to make the world a better place,
Yeah.
right? And I think that always drives me and drives the students that I work with. We're trying to make mechanical components, which is our area of expertise, more energy efficient. So we use fewer of the Earth's resources. Things last longer. You don't have to dispose of them. You don't have to use up the energy to make replacement parts. I mean, it's all right there. But you're correct to say that you have to put it forward when you're, for example, as you said, proposing research to government agencies or even industry. You have to
Mm.
put that forward because it's not present in others' minds.
Yeah, and because it feels like we're in a lot of respects competing for attention with um, what you would probably describe as being, uh, on the face of it, sexier or more exciting fields, right? So, if you're competing for funds with the guys who are doing photovoltaics research, one is more obviously linked to sustainability than the other, even if the impact might be equal
Yeah,
or in our favor, right? So,
absolutely.
how do you convey that message? I guess because that's something that I find
If I had
challenging.
the answer to that, I'd really be in business. But I think it's one step at a time, and it's what you and I are doing.
Mm.
It's just continuing to say these kinds of things to every audience across every platform. I think that, at least for me, that's the best way I know how. One of the challenges is that we as engineers and scientists are often not we're not extroverts.
Yeah.
We're often not out there presenting ourselves. It's something through my career that I've kind of had to force myself to do. To be
Mm.
perfectly honest, is I'm not a natural TikTok star. My most comfortable state is not on a podcast,
Yeah.
right? But it's kind of our responsibility to
Mm.
put this out there, and especially if we have the ability to communicate effectively, to do so, to share our message with as many people as we can, as broadly as we can.
Yeah. It's so funny that you say that because I think a lot of the time, uh, in the field that I work in, we almost face the direct opposite problem, in that in the research and scientific community, you do have quite a lot of introverts, but within uh, a lot of lubricant teams in industry, because you've got a heavy sales focus, And so all the sales guys are like extreme extroverts. so it's a very different challenge. Um, but still that communication of value is something that we still struggle with. And even if you communicate it, it's not like the message is necessarily being understood, I think. So that's really interesting.
You have to target your message to your audience as well. Like, probably the sales guys know this, but in science communication, it's equally as important, right? If I'm talking to an engineer, it's different than if I'm talking to a third grader or anywhere along the spectrum, or my grandma or something like that. You really do have to tailor the message. I don't know if you saw the CBS special the mission. There's something.
Oh
called
yes,
Mission
yeah, I did.
Apollo. That one? Okay, again, that was not my native state. That was extremely hard for me to do. But we spent a long time trying to think about how do you convey ideas of concepts of tribology to kids. And the show was aimed for kids. And I think we were successful, so I hope people check it out. But it's an example of tuning your message.
Yeah, that's very valuable. I've got actually a talk coming up at the LRVS summit where the thesis of my talk is actually that everyone is a salesperson. So because
that's wonderful.
Because the idea is that you're not just you could be in sales and you're selling a widget or something like that, but regardless of that, if you're an engineer talking to your maintenance superintendent, or if you're a researcher talking to government, you're having to sell an idea. And there's actually a lot of skills from the sales world which are would be very beneficial for a lot of people.
Yeah.
Sales isn't kind of regarded as a higher calling necessarily. But you've briefly touched on quite a few forums where you've had discussions, trying to promote the field, whether it's the CBS special. We talked a little bit about the short form videos that you guys are doing. Outside of trying different like media formats and trying to cater to a different audience, what are some of the other things that you would like the Martini research group, I guess, to be able to do?
I don't know. I mean, in an ideal world, we have a broader audience, right?
Yep.
We don't want to be preaching to the choir. We'd like to be able to reach out to more people who have never heard the term tribology, and maybe avoid using the word lubrication engineer if at all possible.
Yeah, that's a familiar challenge.
But I think we're trying, but it's hard to find avenues to get the word out. I think just pushing is one way to do it. Plant a lot of seeds, a few things are going to grow. One or two people see each thing, then you've had a little impact. But I am a university professor, so in the end of the day, most of my impact is going to be at the university level and on the students that I teach. So I'm certainly not throwing that aside for my social media pursuits.
Yeah. So that's a good question as well, because you teach both undergrad and postgrad students, right? You take on PhD students and that.
Mm-hmm.
So there's almost, again, if I had my sales hat on, there's like almost a sales funnel, right? Because you've got the undergrad students of which they might have maybe even compulsory tribology subjects.
No, it's a technical
it's all elective. Okay.
Yeah.
But you probably have quite a few undergrad students coming in, and obviously the funnel gets smaller as you go into the postgrad world. So maybe that's another question is, what do you find is the most effective way of getting undergrad students interested in kind of postgrad research in tribology? Is it purely getting them engaged in those undergrad classes, or is there something else to it?
My first connection point is the undergrad classes.
Yep.
That's the best way. I mean, I do give talks at student group organizations and things like that, but the biggest outreach is probably through the class.
Mm.
You kind of want to keep coming back to the whole sustainability thing that we were talking about earlier. I mean, I'm not incredibly old, but I'm in the older generation now, and the younger people really care passionately and deeply about the world
Mm.
and the global challenges that we face. So it's that you kind of always have to lead with that when you're trying to engage younger people, younger engineers particularly, because they want to matter,
Yeah.
right? All the students that come into college say they want to pursue a career that matters, that has impact. And the logical thing that many people think of is maybe, oh, I'll be a doctor, right, or a nurse, or something that directly helps people. And then technical minded thing, maybe I'll be an engineer.
Mm.
But the engineers also want to be doing something that matters,
Yeah.
that addresses the concerns that they have about the world. So if we can bring those things to the fore as we introduce our field and our topic, I think that's the best sell we have,
Yeah.
the
Yeah.
best sales
Definitely.
we have.
Yeah. That's really interesting. Like the sustainability angle, I think is definitely one of the strongest draws, I think, for
Mm-hmm.
the younger generation. We're obviously facing the dual challenges, though, of people in industry coming from the older generation, and you've got the new people coming through at the same time, right? So that can make it a little bit challenging.
I also though try to hook people with sort of tribology that's relevant every day.
Mm.
And I actively seek out research that is not necessarily well funded, but is very practical.
Mm.
So we've done some tribology on apples, and we've done some fingertip tribology. We're doing wine tribology right now.
I saw one of those papers that it's like why is wine dry?
That's right. So astringency is related to friction. We've done measurements of friction on parchment paper. So I mean, although these aren't necessarily big money makers, they're in you understand them.
Yes.
You get it. Everyone gets it right away.
Yeah.
Sports equipment kind of tribology. So I really try to keep our group's hand in those types of projects as well, because it can be an entree to the field.
Yeah, that's interesting. So, because on the YouTube channel, I've had to probably put a little bit more of a focus on consumer engine oils, right, for passenger vehicles, because that's
Mm-hmm.
kind of that sort of is
Yeah.
what people are interested in, is their own car. And
Mm-hmm.
once you've kind of can bring people in, then you can explore the other applications. So I kind of see what you mean. Maybe kind of going a little bit further on that sustainability angle, because I'm sure this is a question that you would get all the time, is there's maybe a bit of a clash of ideas there, where we're saying, okay, tribology has huge impacts on sustainability in the world, but then people will look at the same time and say, but it's all the oil companies that are involved. How can the oil industry possibly be net good, right, for sustainability? So how do you approach that conversation?
I've never actually had anyone ask me
All right.
that question. That's a good one. You got me stumped here off the top of my head. I would say most students don't perceive it that way.
Yeah. Okay. Cool.
I don't think that they say, oh, this is big oil.
Yeah. Right. Right.
That's not quite the perception. But it's a legitimate point, and certainly from the academic perspective, funding, you have to be funded to support research, and funding often comes from oil companies, additive companies, whatever. But it's not these companies that are I don't want to say causing the problem, but it's not the companies that are generating emissions themselves.
Yeah.
The companies are in a unique position to minimize that because of the breadth.
Mm.
So it's everyone who's driving their cars.
Yeah. Yeah.
It's not it's everybody. Everybody's driving the car.
Yeah.
The oil company provides the power to do so, and therefore has the opportunity to make teeny tiny improvements that have massive impact. So
Yeah.
I don't think I see it that way, and I probably the other students don't too. Maybe they do.
Yeah. No, I just asked the question because I guess, when you are working for an oil company, which I don't do anymore, but I used to, that was always one of the perception challenges you had to overcome. You'd start talking about the sustainability angle of lubricants, and they would kind of just look at you like, yeah, but you work for an oil company. Why?
Right.
Why? And you're sort of saying, well, there is an angle. Just hear me out, and we can kind of get to it. You spoke a little bit about the relationship between kind of the like research community and the oil companies who obviously do their own R&D work themselves as well. So how do you guys kind of fit in, I guess, to the industrial picture? Because I know, a lot of the discoveries that you would be making in the research world are going to make their way out into the real world, and that's where it has kind of like the impact. How does that relationship happen?
How does it happen is often through, I always tell my students, networking.
Yep.
So the connections are almost always made through networking, and you can't avoid that. But I think what your bigger question is what is the role of the university in a university academic partnership? And my view of that is that companies have financial support for somewhat shorter term research goals or development goals, a few years, something like on that order, or less, right? Or maybe 6 months, but something shorter term. But to be looking further out, say to the technology of 10 years or 20 years, there's often not support within companies for that kind of research,
Okay.
right? And you don't even know it's not even clear what that technology would be, right? So you can't say, okay, Rafe, go work on this thing that's going to be important in 10 years, because we don't know what the thing is. So in my view of this, the role of the academic institution is to explore the further down the line technology.
Yep.
Because we can just explore, and we don't run into so much in terms of like intellectual property challenges. It's a little freer on both our side and that of the company, and brings us all towards the same goals. That's kind of how I see it, as like a short-term, long-term research goal sort of relationship.
Yeah. Okay.
Not always.
Yeah, I mean, sort of on that theme, I think, and getting people excited as well. One of the papers that I saw come out of your group, which had me as an aerospace engineer really excited, was looking at, I think it was dry lubricants for the space industry. And that's not an aspect of tribology that I've ever had exposure to, but that is the kind of thing I was thinking, like, as an undergrad student, I'd be all in for that, right? Like, to know that there is work going on in space materials. And again, like you're saying, okay, there is obviously a space industry now, but a lot of the work that you're talking about is for the future space industry as it starts to kind of get bigger. That was to me was like fascinating.
It was fascinating for us. I mean, that getting connected to NASA and Jet Propulsion Lab was gold. It was a gold mine. I don't necessarily mean financially, but I just mean in terms of, as you mentioned, engagement of students, engagement of the media, public awareness. I mean, we had so many opportunities to communicate our message, our standard tribology message, because of the space angle. And everyone loves space. It's cool. Yeah. It's exciting. It's the future. Everyone loves it. But it's also really exciting from a research perspective, because it's driven a little bit different financially. So, for example, this is totally making this up. Yep. Say we develop some coating that has gold and platinum flakes in it or something, right? It's not going to be implemented anywhere in the automotive industry, for example. But NASA might pay for it.
Yeah.
For a bearing that's going to go like this a few times.
Yeah.
or whatever. You know what I mean? So there's opportunities for really interesting technologies that maybe aren't today financially viable.
Mm.
But if we can develop them and prove them for the space application, then maybe things become financially viable slowly over time if they're good enough.
Mm.
Right? So that to me is a neat angle that people don't always think about in terms of space research. And then the other cool thing is that the environment is just wild. It's super cold and there's no air.
Yeah.
So, right? I mean, you're going to send up a standard lubricant up there. It'll be a candle in like 10 minutes.
Yeah.
Right?
Yeah. And I guess
So,
maybe for people listening who most people are not going to have read the paper, but I guess the premise of it being solid lubricants in space is because liquid lubricants just aren't going to work in those temperature extremes, right? So basically everything is a solid lubricant up there, which is very different to the challenges that we face here on Earth.
Right. But as I was saying, perhaps we find a solid lubricant that, again, we develop for space and deploy, but say it's so good that maybe there's opportunities. I know, sorry, oil companies. Maybe there's opportunities to minimize or get rid of the oil for some applications. So I view it as almost like a test bed for future technologies.
Yeah, that's fascinating. And maybe to go from the real far out there, kind of 10 years from now, to research that you guys do, which I'm sort of in some respects fascinated by, because one of the other aspects, rather than talking about future technologies, is a lot of research that goes into current technologies that we still can't really explain. Mm-hmm. So again, a couple of the papers that I've seen come out of your group, things like the role of shear in tribofilm formation, right? Like, to me, that's such a fascinating topic, because I mean, zddp is an additive, like it's as old as they come, right? It's been around forever. And I just found it fascinating that we don't actually have a full understanding of how it works.
I know.
So
it's wild.
So to be able to take some of those insights and communicate them back into the community as well, how is that kind of research viewed as well, I guess? Because do you get questions about, like, why are we still studying zddp? Hasn't this thing been around for like 80 years?
Well, the answer to that question, though, is regulation. ZDP has some nasty stuff in it. Nasty, and it's slowly being phased out in Europe, and not here yet, but it's probably coming. So in terms of the timing of research specifically on zddp, it's because we're looking for greener alternatives. But in answer to your question, sort of more generally about fundamental research, it's actually, I didn't think of this but when I answered your previous question, but another thing that's incredibly cool about tribology is that everything happens between two sliding surfaces. So you can't just look and see what happens, right?
Yeah.
We know that additives form tribal films that are critical to protecting surfaces during operation. Everybody knows that. But no one has ever seen it happen. Nobody.
That's so true.
Can't see it. You can't see it. I mean, people have done tricks where they made one of the surfaces transparent, but then you have a different surface, right? So it's kind of like this hidden, super cool science.
Yeah, it's so interesting to think that, like, it's hiding in plain sight.
Right.
The whole world, it still goes ahead and functions. Like, everyone's got anti-wear additives in their lubricants, but no one's actually ever seen it happen.
Isn't that wild?
Yeah.
It's just crazy. So that's why there's this research.
Yeah, maybe that's an angle that I should try as well, and trying to get people interested, is like the mystery of it.
Yeah.
Right. I'd never really picked up on that there is a lot of mystery involved in lubricants. Maybe I've always tried to get away from that, because we already have a bit of a reputation as kind of being like the black art, right? That people don't really know what goes into any of the lubricants. If I then say that we also don't know how they work, Uh,
Yeah, well, you could frame it like a murder mystery story.
yeah, yeah,
I, well, you could have something, some intrigue involved there. And
yeah.
then ZDDP showed up. I don't know.
That's actually that's a cool angle. I'd never really thought about it that way. Um, so what are some of the to talk a little bit more about the future stuff, because I think that's the things that kind of get people excited, right, and people get engaged. What do you see as being some of um, the really neat places that the tribology community can kind of go to? So maybe if I can frame the question a little bit more. So obviously there's going to be, well, there already are new lubricant requirements. Let's say, for example, for the EV industry, right? That's going to be a whole kind of separate application that's relatively new. Um, then we've also got, again, on the sustainability angle, people looking at the idea of things like ionic fluids, right? So how do you actually take the fossil fuel out of the lubricant entirely? And you probably, in your research, get exposure to a whole bunch of other sort of out there stuff. So what do you see as kind of being like the really exciting fields that we're thinking of, 20 years down the line?
That's kind of a tough one. That's a tough thing because there's so many different directions and it's hard to know which will come to fruition.
Right.
You just mentioned the ionic liquids, which I think are incredibly cool
Mhm.
because, for viewers who don't know what they are, there's two parts, a positive and a negative part. And what's interesting about them is that they can be both a base oil and an additive.
Mm. Yeah.
So they have appropriate viscosity profiles to be a base oil, but yet they line up, they're kind of little guys like this, and they line up on surfaces to protect surfaces like additives.
Mm.
So to me, that's sort of like
Yeah.
something that can be a base oil and an additive is amazing. And there's an infinite, so the positive and the negative are called the cation and the anion, and there's like an infinite number of possible combinations of anions and cations,
Mm.
which suggests tunability,
Yeah.
right? I mean, that idea is another mind-blowing idea is that you can say, okay, for this particular application, we're going to put cation A and anion B, and it's going to give us exactly the performance we need. And this one will use C and F or whatever. I mean,
Mm.
that possibility, it's a paradigm changer for lubricants.
Mm.
So you brought it up, but I particularly am excited about the ionic liquid lubricant angle,
Mm.
and I hope and think that it will begin having more and more impact.
Yeah. Yep.
But that's just one of them. I mean, there's so many exciting technologies that are coming out and research discoveries. It's all just very exciting.
Yeah, and I mean, one of the ones that I have sort of particularly interested in was the is kind of reformulation for use in hydrogen applications, right? Because you can, I think it's something that people don't really think about is everyone talks about, oh, let's convert all these engines to running on hydrogen. I mean, Jenbacher had an announcement the other day that they've got like a full basically product lineup of engines that will now run on, either a mix of methane and hydrogen or virtually 100% hydrogen. And my first thought, obviously because I'm in the industry, is, well, how are the lubricants reformulated to run on that, right?
Uh-huh.
You know, presumably you run. I mean, I'm just thinking out loud. I have no idea, but presumably you run into problems with, I would guess, water content as well, right? Because you combust hydrogen, you get a lot more water than you would with regular methane, and how do you deal with that in the oil system and all kinds of stuff? So, yeah. No,
Yeah, new technologies like that are going to be drivers for tribology. Tribology is a little bit of a follower technology. The example you just mentioned, and then previously you talked about the electric vehicles. This is something that we have to catch up on. Maybe a decade or so back, there was the wind turbines. Wind turbines are getting bigger and bigger, and the gearboxes aren't lasting. And
yeah,
but as other kinds of technology move forward, which they necessarily will, and they all involve stuff that moves. Almost all things have something that moves, and therefore tribology's in there. So it's another kind of along the theme that we've been discussing, challenge for our field is that we are kind of a following technology. It's often not that tribology and lubricants are the leader, and then all of a sudden all these other things are going to follow behind. I'm sure from an industrial perspective, you know what I'm talking about when you say, "Oh, we just changed the design of this component," and then the tribologist finds out like a year later.
Yeah.
You know what I mean?
Yeah.
Like, and so we are kind of a following technology, but maybe sometimes it's good to embrace what you are.
Yeah.
And take the opportunities that come.
Yeah. So maybe one of the other questions I'd have would, we talked a little bit about the idea that, tribology kind of sits at the intersection of so many different fields. And one thing we kind of know from, innovation and studies about innovation is that that's where a lot of innovation happens, right? When you get, either people who've migrated from one field to another and can sort of migrate the findings across. One thing that I was curious about is maybe your group might not be involved in it so much, but medical tribology. There's a whole field out there of, every joint in your body is effectively,
right.
A bearing, for want of a better word. But we don't get the chance to top up with lubricant every couple of years. So, when we're designing artificial joints, we obviously need to have, solid contacts that can last that are very durable and can last a really long time. So do you see any discoveries that are being made in, medical tribology that actually do carry over into industrial? Or are they two kind of completely separate fields?
So I'm speaking a little bit out of my area of expertise because as you mentioned, my group doesn't do bio-tribology stuff, but I do follow it and I am equally intrigued. You're right. I mean, there's people, it's personal, but my grandma's turning 101 this year.
Wow.
And she's still walking around.
Yeah.
She reaches up and pulls things out of cupboards. And as you said, every one of those things is a 101-year-old bearing that nobody designed and nobody took to Jiffy Lube.
Yeah.
Right? So it's a miracle. It's amazing. It's absolutely amazing. And I know of people who study that, and I hope I think a lot of people that study it are working towards improved artificial replacement joints and such. But there must be learning to be gained, some understanding to be gained from how Mother Nature did it, because dang, she did it right, and maybe we can learn something from it.
Yeah, definitely. And I mean, again, when you sort of start talking about that, I mean, that would effectively put, a lot of companies out of business. But I think in some respects, like, that's what a lot of research is, right? You're trying to put yourself out of business. There's all these people studying the cure for cancer. If and when they all hope that they get there, but when they do, like, that's game over for thousands and thousands of researchers across the world. So it's a fascinating field. Look, I think we can probably end it there. Hey, Professor Martini, I really, really appreciate you coming on for this. I think I found it really interesting to talk about some of those like really cutting edge technologies that will eventually make their way down into the industrial world, but at the moment we can just get excited about them. And I also really appreciate the work that you do to kind of get it out there and promote the field. So thanks so much for taking the time to come on.
It's absolutely been my pleasure. I really appreciate that you're making the effort and taking the time to create these podcasts. I think it's a great effort, and I'm happy to support it in any way that I can. Good luck with it.
Awesome. Sounds good. Thank you.